In this part of the tutorial, I'm going to survey a number of implementations of machine ethics. I'm not going to look at all of them because there are a vast number out there, but I'm going to pick out what I think are some of the key implementations and approaches and discuss those. To start with, in this first section, I'm going to look at what I think are three important early implementations of machine ethics. There are a lot of implementations now, which is one of the reasons I'm not going to survey them all, but there were 2 survey papers only last year looking at implementations of machine ethics, and I give you those references here. So if you want to go further into the field and survey what's out there, those are good places to start. So generally considered to be the first implementation of machine ethics is Arkin's ethical governor, and this was originally conceived as a ethical reasoning system that would sit on top of a missile targeting system. So the idea here was that ethical reasoning would constrain the targets selected by the system so that those targets obeyed the laws of war and the rules of engagement for some particular situation. Once a target was selected, the ethical governor also was able to influence the parameters for weapon release and things like that in order to try and further improve the ethics of the outcomes here by, for instance, minimizing collateral damage and that kind of thing. So originally the ethical governor system used a sort of constraint-based system, and you can see that here. So you've got a particular constraint here, which comes from the laws of war, and it prohibits targeting things that are close to cultural property. So that's buildings dedicated to religion or art, so museums and places of worship and that sort of thing. And so the idea would be that when targets were proposed by the underlying system, if they violate this constraint, then those targets would be vetoed by the ethical governor. What you can see in the other picture is an image from the paper where, having selected a target, the ethical governor is now influencing the parameters used for weapons release in order to minimize civilian casualties. So if we're talking about the kind of various taxonomies of ethical systems we were looking at earlier, then this is one which constrains some underlying system. There's some other sort of reasoning happening, and the ethics provides veto and guidance to that. It's also probably explicit. We don't have, at least in this constraint-based, a particular ethical theory, though there's a later version of Arkin's system that's using sort of deontic logic and obligations and prohibitions. And it's probably therefore a sort of top-down approach where we've gone away and we've found out what the various laws of war are that need to be obeyed and then have plugged them into this system. The next important early implementation of machine ethics is the GenEth system by Michael and Susan Anderson. Now, unlike the previous system, which was a governor system, the GenEth system, the ethical reasoning is the entire reasoning that happens within the system. And it's a kind of interesting example in that it uses a sort of bottom-up approach. It is based on machine learning, but the machine learning isn't training up a neural network or coming up with some kind of policy for some kind of Markov decision process. Instead, what the training is doing is making a kind of explicit partition of a multidimensional space. So the idea behind GenEth is that you have a whole load of duties and you may add extra duties as part of the training process. So what happens is it's trained in consultation with particularly the early version of medical ethicists. So when you were trying to get from them which of 2 possible actions were preferable, they also got an explanation from the ethicists. And if as part of the explanation some kind of duty was mentioned that had not been mentioned previously, then this could be added as an extra dimension into the space that could then be explored and partitioned. So we've got some examples of duties here. You have to maximise that you're honouring your commitments. You have to minimise harm to patients. But because in Gen Eth everything is about ethics, you've got some slightly odd duties like, maximising, maintaining your readiness. And basically that is some kind of imperative to go and recharge yourself if your battery's low. So when you have these systems in which every decision made is viewed through ethics entirely, you get some sort of things which most people don't feel are really ethical choices. Should I recharge myself or not? Even though, of course, if you take the global view, if the robot is not available to help someone because it has run out of power, then that can have ethical consequences. And what you do, this partitioning of the space, which you see in this little screenshot on the right, so you're comparing two actions, A1 and A2, to see which one you want to do. And so you compare the actions according to each of the duties. So this bit where it says at the top, for instance, delta on a commitment is greater than or equal to -1, that means, so the delta means the difference. So the difference between action 1 and action 2 with respect to honouring commitments is -1. So that means action 1 is a bit worse than action 2 when it comes to honouring commitments. On the other hand, so you've got and there, it so happens that action 1 is quite a lot better than action 2 when it comes to this prevention of immobility. And this robot is supposed to be caring for an elderly person, so it's supposed to prevent them just kind of sitting still all day. So the idea is that you describe a bit of your space as this is the bit of the space where the difference between the actions in terms of honouring commitments is -1, and the difference between the actions in terms of mobility is greater than or equal to 2, and so on, in respect to all the duties. And then whenever you come across a particular situation, you can plot where it falls in that space, and that tells you whether to prefer action 1 or to prefer action 2. The last of these early systems that I want to look at, I'm going to call Alan Winfield's ethical robot. This is more or less a sort of utility-based system. So in this system, I'm going to show you a little video of Alan's in which one robot is supposed to prevent a human from falling into a hole while also trying to pursue its own goals. The human is another robot. So what you'll see is an arena, and there'll be four little bits of yellow tape which are marking out a square on the right hand side of the arena. And the ethical robot can stop the human walking into that space by intercepting them, and then obstacle avoidance behaviours cause the human robot to move away. And the ethical robot's goal is up in the top right of the arena. So you can see after it saved the human, it goes on to the top right. Now, if you read Winfield's paper, the ethics is described in quite a symbolic way. It talks about if things are better preventing the human from getting in danger or preventing the robot from getting in danger, and there's a kind of if then else. But if you actually look at the implementation in the first version of this, then it's a utility-based system. It's just there are very high utilities for the human being safe, so keeping the human safe overrides all the other things that the robot might be trying to do. So if we look at these three early systems, Gen Eth is working from a philosophical theory called prima facie duties. The ethical governance system of Arkings has this kind of constraint-based thing, but I think the early versions weren't really going from a philosophical theory. It's only when he starts using deontic logic that you start getting something that looks more rigorously philosophical. And Winfield's robot definitely has a utilitarian flavour to it, but I don't think that that was what was foremost in his mind when he was originally pursuing this research. Even though there are later versions of this, several of which use things like Asimov's laws of robotics, not as a kind of recommended ethical theory, but as an example of how an ethical theory can guide these sorts of things. What I'm going to do in the next video in this part is I'm going to look at some clearly symbolic approaches to the implementation of machine ethics, and then in the last part of this section I will look at some more machine learning based approaches.